let's continue in 3. We got chapter 3 today and next Tuesday. And then next Thursday there is no class. I don't have Tuesday's lecture. Well, actually Tuesday's lecture's out there in audio, but it's not out there in YouTube yet. It's converted, but it was converting it while I slept last night, and I didn't have time before I left the house this morning to post it at YouTube. So that should get posted tonight. Today's lecture will probably get posted. It may get posted tonight. It may be tomorrow night, or it may take another day or two. If it doesn't get done by tomorrow night, it's going to be Sunday before it gets posted. Friday and Saturday I'm in meetings with Kiwanis that I got to go to Alcoa for the weekend. I'll finish that sometime late Saturday, visit an uncle, and then come back here, I think, Saturday night late. So looking at CPUs is the next part. We talked about the motherboard already. Is what we just finished talking on. Now we're talking about items that are on the motherboard. With the CPU, you got a variety of CPUs available to you out there. And those 3 things showing there on the screen are going to be your big 3 items that you're going to be looking at in terms of them. Well, speed's going to be another, and those others are going to be items on it, but the biggest 3 is going to be those first 3. As things stand today, as far as your PCs, the Intel and AMD is your manufacturers of your processing units in them. Okay? This course, the test out materials is referencing them as CPUs, is what they're using the term as continuously here. Now, as far as talking to others, etc. out there, there is several different terms you'll see used synonymously on it. CPU is actually the older term on it and not technically correct, but is quite commonly used for it out there. But we're talking about the processor for the computer, so it's really a processor. Central Processing Unit, which is what CPU stands for, is actually the processors on mainframes, okay? Which were large processors on them, entire boards. And that, and then that initially on the PCs and the smaller ones that you did have a name went around for a while, and I still see occasionally mentioned for them as far as the processor on them as a microprocessing unit or an MPU. So just think of CPU, MPU, and processor all as basically synonymous. But they're going to use the term CPU through this book, okay? But if you go and take an A+ test, it may probably won't say CPU, it'll probably reference it as a processor. As far as the microprocessors, the CPUs for the PCs, 2 major producers of those, that's going to be essentially your only producers for those specific ones, is going to be AMD and Intel. Okay, now as far as your processor on your phone and some of your tablets, some of them are using ARM processors, ARM, okay, which is licensed out by ARM Manufacturing in England. That's who's developed them, but it's not who's making them, okay. The Intel and AMD are going to be the 2 big ones as far as the designs of them. However, at this point now, that statement's not completely accurate on that. It is, they are the designer of it, but AMD has essentially that they have gotten out of the manufacture business and just does design of processors and type stuff, and has spun off their manufacturing as a separate company. Trying to think what the first word on it is. Something foundry, and I can't remember what it is. That actually does the manufacturing. But they do the design and the development on it. Now, AMD and Intel build a number of other things besides processors, that they build other components too. AMD owns one of the big video card companies, and I can't think which one of that right off the bat at the moment, but they bought them a few years ago. As far as those two on processors out there, Intel has got the biggest part of the company, of the market on that. As far as just PCs, Intel's probably got somewhere about 70-80% of it. Servers, actually AMD does a little bit better on it, and probably about half of the servers processors are coming from, close to half are coming from AMD. But AMD, between the two, probably only represents a total of 20% of the market at best, and sometimes it's gotten as low as 5%. Intel's got it pretty precisely, and that they set a lot of the standard to it. Accordingly, and they say there that Intel has a larger market share, which is true, and while AMD processors generally cost less, actually by AMD's market plan is that theirs are going to cost 10 to 20% less than a comparable Intel processor. That's actually what their pricing scheme is supposed to be. They have split more as they've gone along, initially up through basically the 486 processor. They were about the same on both of them, and now they've wandered off and gotten more differences between the two of them. Depending on what you're going to be predominantly using on your machine, you may have preference for one or the other, that one processor does some stuff better than the other processor. For a while there, everybody, the gaming industry and stuff, all wanted Intel ones, but now I'm hearing a lot of them. People tell me to get that they want AMDs. The AMD has got better speed for the gaming type stuff. So AMD has been there, and Intel was the originator, and then AMD has been there. There's been one or two other companies were in the market also there for a while, but have dropped out years ago, and they didn't hardly represent any. That they had like 2 to 5% of the market, and they gave up on it. That Intel had so much. I will throw my caveat into this whole thing also when we're talking about these. I do own somewhere a couple of $1,000s worth of stock in AMD. Okay? Well, last I checked, I think I know my laptop computer is running on an Intel. Okay? Which is the latest computer I bought. Because really I didn't even pay attention on what the processor was on it. As far as brand, I was looking for, did it have the capabilities I wanted for it? But I wasn't worried about the brand name. The two of them are going to stay there and stay in business. AMD's not going to go out of business. Intel's going to make sure AMD stays in business. Because if AMD goes out of business, then they got antitrust violations. And as long as AMD has a certain percentage of the market, Intel doesn't have to worry about antitrust stuff, even though they've got a huge amount of the market that they can point and go, there is a competitor out there with us going along. It's just like with Microsoft and Apple, that Microsoft made sure Apple made it through one of their downturns one time, that Microsoft bought part of Apple to put money into Apple to keep them going back in the late 90s when Jobs came back on after he'd been fired, and then when he came back on with them, that Microsoft invested in Apple to keep Apple going because it was important Apple be there.
Why though? Like, is it because they're being generous, or is it for like world, like economy reasons?
Government reasons. Because you can't have a monopoly. If you've got a monopoly out there, you're strictly controlled by the government on what you can do, etc. And as long as you've got competition, the government leaves you alone. And so they want to make sure, so some of these companies want to make sure there is competition there.
Really? What happens if there wasn't though? They allowed.
Then they may split your company up, which is what telephone companies went through. They may restrict you on what you can sell, etc. on some stuff.
Is that weird?
No, that's to protect them from setting unlimitedly high prices on things that they shouldn't be, to keep things more market oriented. So that's going to be the big thing on there, is that, and for some of you, that's an item when you're looking at machines that's important to you, as Intel versus AMD. For a lot of other people, it doesn't make a lot of difference. Because AMD is not as big as Intel, you'll have some consumers out there that really don't know anything on the processors. They got to have an Intel because they don't think AMD is going to be around or something else, or that it's smaller so it can't be as good as they're thinking. That doesn't quite work. The next part is about 32-bit processors and 64-bit processors. That's going to gradually be disappearing as an issue out there for you, and it's pretty well disappeared if you're looking at processors today, because basically everything you're going to look at today is going to be 64-bit. That we've moved to 64-bit over the last few years. But you're still going to encounter 32-bit machines out there for a good while longer. But you're not going to go buy a 32-bit machine. Does everybody follow on that part? So the 32-bit processors is how large of an instruction, of how large of a word can it send across at a time and work with. 32-bit was 32 bits long. 64-bit, you can work with twice as long of a word. Okay? Guess what? It can work a whole lot faster, because it's sort of like if we take the road out in front of here of 27. That if we narrowed it back down to 2 lanes as it used to be versus the 5 lanes out there, the amount of traffic that can go down it, we can get the same amount of traffic down it, but it's going to take a while longer to get cars down it. Okay? If they would increase the lanes for our I-85 and 75 through Atlanta to about 16 or 18 lanes instead of just 4 to 5 lanes in one direction down there, wouldn't be as bad of a traffic congestion on it. So all you're doing is adding lanes into your computer on the processor of 32-bit versus 64-bit. However, the other part that works with that is when we moved forward from 32-bit processors to 64-bit processors, and if you go back to the early 80s, you actually got back to 16-bit and 8-bit processors. Okay, but we've been on 32-bit since back somewhere early 80s. And then 64-bit started appearing, but it was on servers only for a long time, and then when you get to the 2010s, we've moved completely over to 64-bit.
Does the supercomputer have more than the 64-bit?
Yes.
It does? What does it have?
128.
Oh my God.
So, but for a PC, you're looking at 32 or 64-bit now. 32-bit applications can run on the 64-bit computers with some limitations on that. Okay? Occasionally you'll have something that doesn't do. If you're installing your operating system on the client of Windows, you can install either 32-bit or 64-bit. And on a 64-bit processor, you can install a 32-bit or 64-bit operating system. 64-bit applications will not run on 32-bit operating system or on 32-bit processors. Does everybody follow on that? So we can have, the processor can be 32 or 64. If it's 32, the only thing that can come on here is a 32-bit OS and 32-bit programs or apps. If it is 64-bit, we can run a 32-bit processor, 32-bit OS, or 64-bit OS. And on there we can run 64-bit apps, and we can run 32-bit apps. On the 32-bit OS,
It's 32.
the only thing we can run is 32-bit apps. Everybody follow on that? Now, another thing, when you're looking there in Windows, the default place it puts your programs is in Program Files folder, correct? If you look on there and you're running 64-bit operating system, 64-bit Windows, you're going to have two of those folders. You're going to have a Program Files, and you're going to have Program Files parentheses x86. The x86 is 32-bit. Okay? The one that's just plain Program Files on the 64-bit one will be your 64-bit applications. Sometimes your 32-bit ones may not work on your 64-bit because it doesn't have the correct drivers and utilities to work with them included on the 64-bit. But generally your 32-bit applications will run on the 64-bit operating system. Does everybody follow on that? And you can definitely install the 32-bit operating system on the 64-bit processor. And then you can install all of your 32-bit applications definitely run in the 32-bit operating system. Now, I would suspect within 3 to 5 years, you won't have any 32-bit operating systems being released. Linux may still have something out there on it, but Windows will drop it. Windows Server, starting with 2012, no longer has a 32-bit server operating system out there. They only have 64-bit server operating systems now. And so I'm suspecting a couple of more releases on the client, and they'll drop the 32-bit client also, which for the time being is Windows 10, and the way they're talking will continue to be Windows 10. It's just which upgrade are we up to, okay? So they've talked about Windows 10 being a permanent name. Everybody follow on the difference between 32-bit? So you'll also see that out there as x86 and then just as 64. That if you see either one of those, they're talking, if you see something out there referencing about x86, they're talking 32-bit. And that goes back to the processor. Those were all, the processor names used to be with 86 in the processor name for the old ones, and that's where that came from. Now they're 64-bit ones, and we just put 64 as the name for those. And then, like I commented a minute ago, there is 128-bit processors out there now, but they're very high end.
It costs a lot.
Mm-hmm.
How much do you think that would cost? Like $5,000?
I have no idea what the amounts are other than they're expensive. All right. We used to have single core processors, which meant that it just had one thinking unit built into it. With the multi-core processor, what it's saying is it can split and think several things at one time. So it's basically like it's multiple people in it, but it's splitting it up in there. It's multiple processors in one processor. Y'all follow on that? So when it goes to run stuff, it can assign apps out to different ones of those multiprocessors so that they can run in parallel, or it can actually split an application and do part of it in one processor, part of it in another, and part of it in another. And guess what? It can get it done a whole lot faster than where it was just doing it through one processor. So how many things can it handle at one time is what's going on there. Your 32-bit machines tended to be single processors, but they started going to multiprocessor also. But particularly where you're going to find the multi-core one is with the 64-bit. It says there, dual core, triple core, quad core are typical in desktop systems. Even though they just came out with this thing here, that's not quite correct. I've never seen a triple core as the first thing. Okay? They tend to fall in even numbers. So I'm not sure where that triple core came from, because I've never seen anything about a triple core processor. I'm not going to say they don't exist, but I'm not aware of them. Okay? Dual core was the initial. There weren't a lot of dual core machines done. We went quad core pretty quickly on that, but there is some dual core stuff still floating around. Quad core is what most of your machines are today that you're getting, is that they're quad core, but they could be 8 core or 16 core. And I don't know words on those. I don't remember seeing words for them instead of 8 or 16 on them. But you do have 8 core and 16 core desktop processors. Okay? If you're looking at a high-end gaming system, you're looking at those. As far as business machines, they're looking at a quad core do their job quite well and a lot faster than what they were used to on their old single core machines. Those at the back of the room, I suspect, may be single core processors in them that y'all took apart the other day. Y'all's machines should be quad core that y'all are working on right there. So you do have that, but it's their ability to run things literally more at a time going through it, that they've split. They've gone to multi-personalities is what it is. Okay? And the more cores in it, the faster it's going to run. Even given the same speed, which is our next thing. So you have not seen speeds of processors significantly increase in recent time. It's been more of making it to the multi-core. So that if you go before, from say 2005, 7, back before that, speeds were increasing drastically every year and a half. And there was actually a thing out there that said speeds would double every year and a half out there. Since that period, that we haven't done a whole lot up in speed. That if you look back to 2007, 2008, you could get a 3 gigahertz machine then, which is the clock speed on it. If you go back in time, you went to megahertz and khertz, on speeds of them. But if you go and buy today, you're still looking at somewhere in that 3 to 4 gigahertz range, but instead of being just a dual core or a single core processor, you're looking at quad core, 8 core, and 16 core. Guess what? You're doing, because you're splitting those personalities to it, those multiple cores, you're basically multiplying times speed on it. Okay? Does everybody follow on that? So, like my machine that's 7 years old at home is a quad core machine that happens to be 2.3 gigahertz on it. And yet, if we were to look at these, I suspect these machines are probably only about 3 gigahertz. Not a huge amount difference in speed on them. Okay? So, you do have that with the multi-core ones. Everybody follow about how multi-core is working? So it's the ability to do more things and keep track of it separately at a time. Speed is in terms of that internal clock, and where I mentioned on the clock the other day, I believe in here, that is how fast is it able to do stuff. That you see that expressed in, it says here in megahertz. Doesn't sound right. Maybe it is. System. Should be up here. Why is it not there? Yeah, there it is. I knew that was wrong. This ain't gigahertz now. I know it's gigahertz. I was going to make sure on it that it wasn't my imagination. They say it's measured in megahertz, it's measured in gigahertz. They're left over from somewhere in the early 90s. Okay. So in the case of that machine, which should be the same as y'all's machine sitting in the room, that this is an Intel processor. It's an i7, and that is running at 3.41 gigahertz. And like I say, mine at home, if I remember right from the number I saw last week or something when I looked at it to see what speed it was 2.3 or 2.5 gigahertz. So some difference on it, but similar. Doesn't tell us right there on it, but I'm pretty sure that's a quad-core processor. But notice it is a 64-bit processor right here. And then we have chosen to install on it a 64-bit operating system. And but big thing on that is, remember, you can't put 64-bit on 32-bit. Cache is the memory within the processor. You've got memory on your machine, which we're going to talk about later. But in the processor, there is memory there also, which is what it is currently working on. Okay? The bigger the cache is in there, the more it can have stored in there that it can currently work on. Think of the processor like your brain. Okay? One of the big things you think about your brain is that's where you think, right? Well, that's the part we were already talking about. Well, the second part of your brain is what else goes on up in your brain. You store a lot of information up there. That is information that you process at different times, right? That's also part of the processor. It has got memory inside the processor. That is what it's working on, which is like memory up here. In addition to that, you can store stuff out there that you work further on. and that gets into the memory in the hard drive, okay? But the cache, as a note there, that it'll talk about L1 to L4 cache. L1's the smallest, L4 is the biggest cache. And that's integrated on the processor itself. L2 has for both the instructions running through and data, additional space for that. L3 goes a little bit bigger but works with multi-core, so it keeps it up for, has memory sitting there for both each of the processors. And L4 actually gets the graphics processor included with it, of having memory for the graphics processor. You've got a separate graphics processor on there. Process size is just the manufacturing process to put the transistors into the silicon wafer that becomes a CPU. Not something that you ever see much on. Hyper-threading. That goes with the Intel processors. AMD has got a similar thing, but I can't remember what they call it, and they don't even mention it here. But hyper-threading allows a single processor to act similar to a multiprocessor, and where it can split things into different threads and work with those at the same time. And then they note there is multi-threading is actually where the application sets up multiple threads at the same time, but a lot of people are going to consider multi-threading and hyper-threading essentially the same. But multi-threading is going to be within the program of splitting it up. Hyper-threading is where the processor handles it. Multi-threading has been around for a long time, but it allows programs to split off into separate threads and do that section of the program separately from the other part. When I wrote my student records program for Swainsboro Tech back in the 80s, I didn't realize what I was quite well doing on it, but I did multi-threading into it to make it work faster, and where whichever thing you were doing, it just spun off a thread for you and did that section you were wanting to do. It made my program run a whole lot faster, and it was after I'd been doing it that I found out what I was doing. And then when multi-threading got big in the 2000s and hyper-threading came along too, that I suddenly realized quite well what I had done and that I'd been ahead of the game on it. And that when we switched computers, that when we went to an IBM machine, it did not allow me to do multi-threading, and it was a whole lot faster machine, but I couldn't multi-thread, so I lost that part, but I gained the part of it was a lot faster machine and netted out about the same. Other people said about how much faster the machine was to them when they moved their programs over, but they've been complaining about how slow their programs were compared to my programs before. Throttling is the ability to speed up or slow down your processor to minimize your consumption of electricity and your heat output. The higher you throttle it, the more heat you're going to generate, and that you got to cool it better. And that so then you may throttle it down to cut down the amount of heat being generated, because once it gets hotter, it gets slower. Overclocking, some of y'all can probably describe that one better than I can and have done it where I haven't. You can take a processor and get it to run faster than what it's rated at. However, when you do that, when you overclock it, you are running you are going to get that increased heat, and it is going to use more power on it. Okay, so guess what? You got to have a bigger power supply to handle it, and two, it generates a lot more heat, so you've got to have the ability to keep it cool on it, and that if you're not careful when you overclock processors, you may well burn them out, literally. Okay, because they're not designed to handle that additional heat. That what they have built it there and set the speed on it at is with the bit of it being able to keep cool and operate efficiently at that. But you can go in, cause them to run faster by overclocking, but you've got to be careful on doing that to make sure you keep it adequately cooled. How many of you have overclocked the processor? Any of you? You got one. But just be careful on doing that. People do it on their phones also, and everything we're talking about here basically applies to phone also, except phones tend to use ARM processors instead of Intel and AMD, although they could use an Intel or AMD also. Okay, and then mobile ones they mentioned here, the separate CPUs built for those, and they're built, it says there, to minimize power consumption and the amount of heat generated. If more heat it gets to generating, that slows it down, and also your power consumption goes up. Well, on our phone and our tablets and stuff, we get real concerned about power consumption because that means it kills our battery that much quicker. Virtualization can be built into the processor also. And if you're going to run virtualization, your processor's got to be designed to handle virtualization. Because what is virtualization? It's where you're running imaginary machines inside machines. And as long as the processor's designed to handle virtualization and your CMOS setup, you actually have the capability, if it can do virtualization, to turn on that ability or turn it off. But if it won't support it, you can't do it. Now, all of your processors today are going to handle virtualization. It's just a question of, do you have it turned on or turned off? Okay? But virtualization will allow us to create imaginary machines within the real machine. If any of you take my server classes or have taken my server class, Todd, did you take the server class or not? Or the Windows 7 class? Did you take Windows 7 or server from me? Okay. But if any of you do, you're going to use virtualization for those classes. And that you'll create a machine within your machine. That's all virtualization is. And then you can have some other things built into there. You can also have, with your processor, you are going to have cooling capabilities on that processor. Now on the laptops and tablets and stuff, it's definitely an air cool issue and trying to best figure out and getting your fan close to it because you don't have a lot of space, airspace around it. And your PCs, that you got lots of airspace around them, but you still got a separate cooling unit on it. You'll have the cooling towers on it with all the fins to draw off the heat off of them. You'll have fans built onto them, etc., to keep that processor cool. And in the laptop, a lot of times that is the fan you got is sitting right there with the processor to keep that cool, because that is going to be your biggest heat generator in that machine, is that processor. All right. I really told you all that stuff. Intel and AMD ones, and even within Intel and AMD, they're going to have several different type sockets that the processor plugs into. So if you go to get a new processor, one has got to be the same brand as what you had, and two has got to be the same type within that brand, because there's different types of them and they have totally different sockets that they go into. So you have to use the appropriate ones for that. Y'all have already actually seen how to install one. The one thing we did not do is that when you put the heat sink on there, normally you would put a layer of heat glue between the heat sink and the processor, which draws the heat more efficiently out of the processor into the heat sink. Okay? Because it makes a contact into the process between the processor and the heat sink, and it draws the heat off of that processor quicker on it. But we're skipping the glue in here. And it's a white glue that you put on there. And it's just some gooey stuff that you put in there. And then the CMOS may have to be set up accordingly for it. I may have to go to Walmart and buy myself a couple of clocks to put in these rooms, because I keep looking for a clock. And since we can get wall clocks for what, $5 at Walmart or something, I may just go buy a couple of them to hang around. It's easier looking at the wall than looking at my watch or my cell phone. Usually you'll get a post error about if it's a processor problem that will tell you that your processor's failing on you. And again, back to those beeps and stuff. Memory. It is going to be in those cards that you put in, like y'all took out and put in the other day. That goes in them. So we're going to have a variety of types of those, and they will run at different speeds. Also be measured in terms of the different speeds to them. They talk about SRAM and DRAM, and then varieties of that, and then they show you some cards of that. And notice they all look somewhat similar on it. The bigger the numbers on them, the faster and it's going to do, and the bigger the capabilities is on it. SRAM, it notes, is mostly used in cache memory now. DRAM, it says, is relatively inexpensive. Memory's gotten a whole lot cheaper, and that it's your main system memory on the machine. SRAM isn't going to require constant power to maintain it. It is static RAM, but it is RAM, so it's random access memory. So if you do kill the whole bit back to it, it is going to, SRAM actually does hold on it to a degree, but dynamic RAM is going to work more like RAM really works, and when the power goes to DRAM, everything's gone out of it. SRAM, it does have the capability to hold itself for a little bit with no power, but it is RAM. Then they talk about the DDR, DDR2, DDR3, DDR4, and that's going to get into your transfer rates and your bandwidth of how much it can take across at a time, and what the rate it can transfer information off of that RAM on it. Now, you're using cards like this in all of the cases. Now, in your laptops, they're only half the size of that physically, and your desktops, they're the full size, which I'll handle the other day, but it's the same basic thing. It's just the sizing on it. If you do decide to change the memory in your machine, what you've got to do is look up on your machine and see what type memory will work in it, and your memory limitations in terms of size, of memory size. The memory is where it's holding the stuff that it's working with. The more memory you've got in there, the faster your machine is going to work with the same processor. Does everybody follow on that? Because it can retain more that's working with it at that point. If it doesn't have enough memory on it, what it has to do is swap it in and out with the hard drive on it, and that slows things down when it's got to keep looking back to it. The more information you can carry about in your head about stuff, means the less you have to look back at a piece of paper and the quicker you can give me an answer, right? But if you have to look back down a piece of paper to remember how to do something, slows down how fast you can do it. Then they talk about the DIM and the SDIM. The SDIM actually goes to using in the laptops versus the DIM is in the desktops. And notice it's the half size on it. It's got chips onto there, which are manufactured on there. If you go back to original memory on PCs, and I will bring in one day to us an old memory board from a PC from back in the 80s, those chips were completely removable, and if you wanted to add more memory to a machine, you plug more chips into it. And I'll let y'all pull a chip and put the chip back down. We'll look at it and let you see what was involved in the past. Now you just swap these cards that got the chips already built onto them. Does everybody follow on that? So it's gotten a whole lot better over time. If y'all had done this back in the 80s, doing a memory upgrade was a tedious job because you had to plug in 9 or 36 separate little chips onto the board. And that was a good bit of work. Memory speeds, they mentioned about those. That's going to come onto it. You're going to usually see that expressed in terms of the numbers after them, which don't go back to the bus speed, oddly enough, that they run into other numbers from them of doubling and so on them. But they'll have some relation. The bigger the number after it, the faster it is. So you notice these about a variety of DDR, we're 100 to 200 megahertz, so where we're talking about DDR3 at 900 megahertz, so almost a gigahertz, and DDR4 that we're getting up to 1.6 gigahertz and such on it. Although they are correct on that, they still express those all in megahertz, even though they're up into the gigahertz range. And then they talk about installing on it. If you're buying on it, like I say, definitely look up first before you go to buy. Look up your motherboard and see what type memory it takes and what's the maximum size memory. Because even though they may have bigger size cards, memory cards out there of that type, if your motherboard will not handle that size, it won't handle that size, even if you buy the bigger one. You may be able to physically plug it in, but it's not going to work. It may work, but it's only going to work on the amount that you had there. Back to the 64 versus 32-bit. 32-bit processors could only handle up to 4 gig of memory on it, okay? And if you're going to go bigger than that, you have to go to 64-bit. You can have more than that sitting there with a 32-bit processor, but it'll never use that higher end memory. Okay? So you really do want 64-bit processors and 64-bit operating systems on your machines. Memory facts, we've talked about all of that. Measured in megabytes or gigabytes. You're measuring in gigabytes today. Frequency, that's measured in gigahertz today on it, where they said megahertz. Latency is the delay from the memory to the processor. It takes time for it to travel across there. The smaller amount of the latency, the more important. Parity. Some RAM has parity on it, some RAM does not. What that does is that it adds, for every 8 bits, it adds another bit on there that tells us whether it's an odd number of bits or an even number of bits made up the other 8 bits that are turned on, and that it's an error checking method for knowing whether you've got a bad spot on that memory or something got damaged to what's stored in there. Single-sided, dual-sided. Most of it's going to be double-sided for you today, but you can still get single-sided memory, and that's just a question of, do we have the memory chips on both sides of the card or on one side of the card? Not anything really big on that one. And then you can lay chips out and look at them and compare them to know on that sum. I've never tried to remember all of that. Be careful in installing memory. ESD is an important one in there because you can damage your memory if you throw a static charge on it. So you do want to ground yourself when working with memory. If you're storing the memory that you've taken it out and then you're going to store it, put it in an anti-static bag. Do you all know what I'm talking about on an anti-static bag? They're plastic bags, but they've got metal built into the bag to keep it from getting a static electricity charge to it. So they've got a metallic look to the plastic, and that they won't pick up static electricity to them, where you're used to. Normally, if you pick up a plastic bag, it can get static electricity real quick to it, right? After all, that's the way Glad wrap works. That's what makes it cling to whatever you're sticking it to. It's actually working off of static electricity. That's that cling factor. Okay, there's memory testers out there, both software and hardware ones of them. MemTest is a real good one as far as a software one that you can go out and download and run it against your memory, and it will tell you if you've got if your memory's bad or not normally. But it can test your memory to find bad memory cards in your machine. Now, I have had memory before that in a specific machine it would throw an error on it. An HP computer I had back in the late 90s, it detected one memory module I had as being a bad memory module, and it would throw an error about it if that memory module was in there. I pulled it out, the machine was happy, took a computer store where one of my students was actually owned. He tested on the memory tester he had there. It said it was perfectly fine. I took it back home, put it back in the machine. Immediately when I booted up, it told me I had, in the post test, it told me I had bad memory, because the HP post test included that in it. A lot of post tests don't. I stuck it in another machine. It didn't tell me about anything bad about it, and I ran MemTest against it. MemTest said there's no problem with this memory. Took it back to the guy again, and he stuck it in again. He said works fine for him, and he had another machine there he was actually needing to replace memory in that was the same type memory as mine. Stuck my card into it. That machine was happy, and he went over, pulled one off the shelf, a memory card, and gave me another memory card and said, I'm just swapping it with you, because he said I'm putting it in this customer's machine, and unless they have a problem with it, he said, we haven't got any problem, everybody will be happy. He said it appears to be there's a bad bit. The HP looked specifically at that bit, and nobody else paid attention to that bit on my memory, and that nothing else was detecting it on it. And I went away happy, and mine kept on working, and he never said anything about having a problem with that one. If you see on your reports that you've got real high disk usage, you may well have either a memory problem or you don't have enough memory. And that because it doesn't have enough memory, is having to write stuff that should be into the memory out there onto the disk into a virtual memory file on the disk. And that it will create imaginary memory on the disk beyond what you got. But that does not run as fast as real memory. Or if you get not enough memory or out of memory errors, one, you can go in there and probably increase your virtual memory and may be able to help solve that one. But if you see high disk usage after that, it needs more memory, so it won't have to be reading and writing as much from the disk just to do its processing capabilities. Other memory type things quite often will tell you in terms of either beeps when you're booted up or display a message that tells you that something's wrong on it. Usually when memory fails, you're not going to boot up because it doesn't have any memory to use when it's booting up. And so you're going to get beeps about it or a display message at post time telling you you've got bad memory. Questions on memory? BIOS and the UEFI, we actually pretty much talked about this stuff the other day. Unified Extensible Firmware Interface is UEFI. BIOS, they're both the firmware that tells your machine how to run. It's not running anything, it just tells the machine how basically to run. That's just like your body. There's some basic functions that it knows what to run. That's running off the BIOS in your system. That keeps the heart beating, tells the heart to beat continuously, and also has the basic functions of how to send the nerves out to control your hands, etc. But as far as what we think in there and all the stuff we build in there, it's what you could do when you were born. Okay? And if you've ever seen somebody that's gone into a vegetable state or whatever type thing of the state where they get into, that's what keeps them on alive at that point, even though they have no thinking capability, etc. out there. It's just here we're talking about the BIOS and the UEFI. And so those are on there. UEFI is the current new way to do it. It's replacing BIOS. But your machines at this point are giving you both BIOS and UEFI on them. They're running in UEFI unless you go into the CMOS and tell it you want to use BIOS instead. However, there's times that where you want to get in on a lower level, you need to put it back to the BIOS to be able to get to that lower level that UEFI won't. UEFI will allow your machine to boot faster than BIOS does. UEFI will support larger hard drives. That's not correct either right there. It tells you here that UEFI supports drives larger than 2.2 terabytes. Okay, that's correct. BIOS is only going to support up to the 2 terabytes on it. The UEFI is going to let you go to much larger hard drives. And guess what? They are getting those drives, and some of you probably already have larger hard drives than 2.2 terabytes. Because I've got a 5 terabyte external hard drive on my machine. And I'm usually behind some of the students on that one. Because if y'all are doing videos and stuff, you've got to have bigger ones if you've got very many videos stored on your machine. And the CMOS is where you keep the settings that the BIOS and UEFI use to boot the machine from. And there you've got settings in there. You can set the clock in there. You can set some other different settings in there. You can tell it what devices is it allowed, should it even consider looking at which ports and stuff, and which ports are you disabling at that point. So to edit those, you're going to go into the CMOS. Now, you can update the BIOS and the UEFI by flashing it. And that's where you get a program that then goes in, because the firmware is permanently written out there, but it can be updated. So it's not really ROM, but it's firmware. That it's changeable permanent. Does that make sense to y'all? Where RAM is just purely temporary. Okay? But UEFI and BIOS, you can go out and if they find, like to allow newer devices to work on your machine, you may have to boot to flash your BIOS and UEFI for it to be able to work with newer devices or newer type ports. Or as we come up with bigger hard drives and such things, that you may have to flash it to be able to support larger ones on there. So there is reason to do that, and it flashes it, and when you do that, you're doing it before you tell it with the machine running, and then it says it's got to reboot, and it does it while it's in the reboot part, because it does it before it actually even thinks about loading Windows or anything else on your machine. If you do go to flash your BIOS UEFI, when you start that process, one, don't do it when there's a chance of the power going out, because if the power goes out while you're doing that, you can lose that whole thing on it, and that you'll have to go get another new motherboard for your machine. Okay? So don't do it when there's an electrical storm approaching. If there's been electrical problems in your area right there, wait till everything's steadied out. And that you don't want to turn the machine off while it is doing the flash of it, while it's updating it, which is called flashing it. We'll leave it running and let it run. Now, usually it can go ahead and get itself straightened out of it if the power does fail on it, but you can destroy the machine on it if the power goes out in the midst of a flashing. So just be careful with flashing it if you do go to flashing. And then you just go to CMOS, or when you're booting up, if you have it set to display the BIOS settings as it boots up, which you can hide, and UEFI wants to hide those all by default, which is where it makes it faster than the BIOS. So you can find some of that information. Or else, when you're booting the machine up, it's usually either the escape, the F1 or F2 or the F12 or the delete key that will take you into the CMOS settings. One of those. So when I go to work on a machine that I need to go back in and look at the CMOS, I'm sitting there and pressing escape F1, F2, F12 and delete while I'm booting, that I keep bumping all of those keys on and off as it initially boots, and that's before Windows even starts to think about to load. Usually it will, a lot of times it will just play a message down on the bottom of the screen for you that tells you press whatever key for CMOS setup or for setup. It usually just says for setup, but it may only appear there momentarily for you to see, and you may not even see it flash by on you. So keep but like I say, those 4 key, 1, 2, 3, 4, 5 keys, one of those 5 keys normally does it. You can also go out and look up your motherboard processor and see what the actual key is supposed to be for yours. But one of those keys is going to do it for you. To clear your CMOS settings if they get messed up, or you got a password set in there for booting up on, there's a couple of ways that you can clear it. You can actually, when you boot, go into it and you can tell it to set it back to the default settings. Or the other one is, if it's a desktop machine, if you'll open it up, there's somewhere on the motherboard, there's a 3-pin connector with a jumper sitting on it that says CMOS by it. And that if you move that jumper to the other, turn the machine off, move the jumper from the 2 pins it's on, so there's 3 pins sitting there. The jumper is like sitting on those 2. If you switch the jumper to sitting on those 2, if turned off, turn it back on, it will have cleared the CMOS at that point and you're back to your default settings, which includes clearing the password, which is what that's normally used for. And that's all it does right there. You don't have to set it back to the way it was before. It doesn't care which 2 it's set on. It's when it gets switched to the other 2 that the other one of it, that at that point it clears the setting when it turns on. And I think that's going to take us through that. Let's stop here and talk from expansion cards on Monday. Okay? So we got class Monday and Wednesday next week to cover on this. But we got class both days next week. Those of you that are in the Cisco class, we only have class on Tuesday next week. And I think I told my other class that we didn't have class next Thursday. Well, that really doesn't make any difference because their class doesn't meet on Thursday anyway. And I'll put it out there as an announcement that I'm going to be off campus Thursday also. Actually, I will be off campus when I get out of the afternoon class next Wednesday, I will leave school and head for Macon. Because the drive to Macon is part of my work day, so guess what? That'll be a long work day again. Any questions?